Okay, hello, welcome. So my name is Clement Escoffier. I'm working for Red Hat in the Vertex team as a Vertex core developer. And in this talk, I'm going to show you how reactive and how using a toolkit instead of a framework or app server will give you a freedom that you have lost long time ago. And which is that because of this freedom, you will be able to express your creativity again. So I named this talk the Reactive Cuisine because I don't know if you Google my name or if you check on Wikipedia, you won't find me. You will find someone called Auguste Escoffier, which is a very famous chef, absolutely not related to my family because I'm really bad in the kitchen. And I was thinking that, yeah, well, the idea behind Vertex is to provide a lot of building blocks and putting all of them together and try to build your solution. So, but the first thing is, what does reactive mean? And reactive, if we take the definition from the Oxford Dictionary, means something that reacts to stimuli. So if we apply this definition to software, we can say that a reactive software is just a software or an application that shows responses to a set of stimuli, whatever those stimuli are. There can be message, there can be requests, there can be metrics, there can be availability, unavailability, network description, failures, whatever. Just react. And in this reactive landscape, we have three main areas. The first one is reactive systems. Reactive systems has been defined by the Reactive Manifesto a couple of years ago. I can't remember, 4 or 5 years ago. And the idea is to say, well, let's build distributed systems the right way. Because right now, building a reactive system is a nightmare, and there is a good chance that they are going to fail. Well, actually, they are going to fail. And when something fails inside your distributed system, it cascades over your complete system, and you don't want that. So what they build in this reactive manifesto is to say, well, reactive system must be asynchronous. And that makes sense because network interactions are asynchronous. And if we infuse asynchronous inside the application code, then we will be able to enable resilience and elasticity and being responsive, meaning your system will still work in face of failures and when the load is fluctuating. The second part is reactive programming, and a lot of people consider this as reactive, but reactive is much bigger than this. Reactive programming is just a set of APIs, generally one API, that let you compose event-driven and asynchronous software. It basically means that you are going to handle something called data streams. Depending on the APIs, they have different names. And this data stream is natively asynchronous because you are subscribing to a stream and you will be notified when you get some item inside this pipe. And you will be able to process it. And what you will be, on the output of this is going to be another stream, and so on. Here, so we have streams, flow, event, and spreadsheets, Excel, and so on, are actually about reactive programming because when you write formula, it's subscribed to the stream of value you have written inside the formula, and as soon as this value changes, it reacts. The last part is actually very important and almost hidden today, but we need to be aware of this. Reactive streams. If you are using data construct, data flow, there is one big flow with data flow. If you are sending too much data to a consumer that cannot keep up, your system is going to die. Because the first thing you will do is say, okay, no problem, I will put a buffer in between. Good idea. And what happens when the buffer is full? You crash, or you run out of memory. So reactive streams is actually a very small API that enable a back pressure protocol between a consumer or data producer and data consumer. And so this back pressure protocol just means that the consumer will tell the provider how much is able to handle. So if you apply this, your system is going to be, well, the capability of your system, your capacity of your system is going to be auto-determined by the system itself. But all three reactive things are about being asynchronous. Asynchronous, that weird idea that all developers forget in the 80s. Since the 80s, we're all writing code the synchronous way, because asynchronous is hard. But we have reached recently, especially with this new world of containers and cloud, a limit. Because ideally, when you have 3 requests to handle, for example, you will handle the first one, you will handle the second one, and you will handle the third one. Fine, everything is perfect. Fortunately, in the real world, you get the request, and in the middle of the request processing, you need to do some I/O stuff. Calling a database, writing on the file system, doing some logging, whatever, anything. And during that time, you're stuck, you're blocked, you are waiting. And when this I/O is done, you will continue until the next I/O and so on. So you are actually spending a lot more time. So how do you handle more than one request at a time when you are in such kind of model? And here's a very bad idea. You use a thread pool. And now you have another issue. How much thread you need to have inside your thread pool? And there is no answer to this question. We don't know. You cannot plan the future. You cannot plan the load. You cannot plan when the threads are going to be stuck, and so on. Fortunately, in the 70s, because nothing is new in computer science, in the 70s, there is some people that say, hey, let's do something different. Let's do something where everything is asynchronous, and as soon as a task cannot make progress because it's doing a blocking I/O, it releases the thread, and the same thread can execute another task, and so on, and so on, and so on. To do that, we need non-blocking I/O, so every time that you plan, you can't make progress because you are delegating the work to another system, like file system or database, we need to release the thread and be notified when the answer comes back. We need a task-based concurrency instead of thread-based concurrency. And this is a big shift. And to do that, as we are developers, we need an asynchronous programming model. And these 3 things there, that's what Vertex provides. Vertex is a toolkit to build distributed and reactive systems. It has been designed with reactive in mind since its first line of code 5 years ago. It's not something that we have added as an afterthought. It's something that we are built on with this idea. And we have a lot of production experience about reactive in production. Sometimes good, sometimes not that good, but we fix it, we improve, and since 5 years it has been a wonderful journey, and we are now able to say that we have a very, very nice solution. We provide not one, but several asynchronous non-blocking development models, because we are all different. We are all different backgrounds. Some of you are maybe Scala developers, some of you may be like Kotlin, some of you may be like Groovy. Or some people are more in the Java world and want reactive programming using RX. Simplified concurrency. Again, task-based, not thread-based. One thread. Polyglot, I already said that. A very big and thrilling ecosystem. We are going to see that. And Vertex is used in many, many different domains, like microservices, web app, IoT, API, gateway, high-volume event processing, and so on. This is production use case. This is not POC. This is what people are actually using in production. Okay, and one of the main ideas behind Vertex is a freedom. Vertex is a toolkit. It's just a jar file. You have a Spring app. Put this jar file in your Spring class, in your class path, and you're done. You can use everything that Vertex provides inside your Spring application. Same thing for JavaDay, same thing for whatever. In this demo that I'm going to build, I'm going to use standalone Java app because, well, that's nice too, right? Just a very, very simple class path. Still didn't really investigate Java 9, even if we support it. But I will still use a class path approach. And you will see that we will just do everything by yourself. And we will shape the system as we want it to be shaped, as we want to behave, and not following the rules from a framework and say, oh no, you need to write here, you need to do that, you need to use this annotation, and so on. First use case that we are going to build, something that is very trendy today is, especially in banks, is you have a set of existing services and you need to provide a new API on top of it. And the sponsors, there is a couple of banks, and there is something very cool that is happening in the bank world today, well, nowadays, I would say. It's around fintech and open banking and so on, is that they need to deliver new services. But unfortunately, most of their services in banks are developed in COBOL. Seriously. They still have COBOL, they still have CORBA, they always pick very cool technology, right? And they don't want to rewrite this, so they need a way to orchestrate all the services to provide your new service. And that's what we are going to do there. So the first thing is that we will have an HTTP request that would hit our new service, and that will first call the customer service, get the answer, and concurrently call the balance service and the debt service, aggregate that, and send this back. Okay. So can you see the code? Is that big enough? Or should I increase the font size? Is that okay? On the back? Yes? Okay, so the first thing I will do is to create a Vertex application. So I will just create a Vertex instance. Done. I now have a Vertex instance. And then I will do the Vertex hello world, because we always need to start by an hello world. I will create an HTTP server. I will write a request handler. And I will say hello. And I will listen on the port 8080, which is hopefully not used. And I'm going to start this using right-click, run. No plugin required. That's a Java app. And if I do that, it's running. I will go there. Hello. Something that is interesting to add here is to say, OK, what thread has handled this request? I'm going to restart that. Event loop thread 1. And if I refresh my page, so I don't know if you see that I'm refreshing, it's always the same thread. Because my app is single-threaded. I don't need, nothing is blocking. So it will just get the request, write it. And if there is another request happening at the same time, as soon as I'm done with the first request, I will do it. So we are really in the ideal world that I have described. It will just do everything. OK, cool. But first thing I will do is I want to have some live reload, because I don't want to restart my application. So I will just launch Maven that will monitor my code and just reload it. So that should be fine. I will just check that it works. Yes. And now I want to do my new API. So I'm not going to do that. I'm going to deploy a vertical. A vertical, just a piece of code that runs on top of Vertex. And this vertical is named Gateway Vertical. There we go. And now we have some code to do here, because it does nothing by default. So if I do right now, it just say, yeah, sorry, resource not found. Maybe we need to fit something. So it's not a complete REST API, but just to give you an idea, inside the Vertex ecosystem, we have this Vertex web component that will provide you everything you need to do REST CRUD kind of things. And how it works, you will just say, OK, every call on the slash, I will call this method, and this method is called compute. And now, what does compute do? Nothing. So we need to fix that now. And you just pass the router as a request handler, and every time you get a request, it will look at the routes, find the right one, call it. And you can chain routes and stuff like that. So here, I need to call my first service, which is a consumer service. To do that, I will use web client that I already have it. That's my call. I want my bank account, and I will just do send. And here I should have a result. But as it's a remote interaction, it may fail. So I need to check if it has failed. And if it has failed, I will just generate a 500 response with the cause. If it was successful, then I have the result. Result. This result is an HTTP response. And just for example, just to start, I would just say, OK, let's write it down to see what we have right now. Body as buffer. And if I do that, this is the call to my customer client. So I've called my new API that has called my customer service, just get the answer, and reply this. So my name is Clement, and this is my bank account, which is obviously a generated UUID. Okay, but now I want to call another service. Oh, so if I want to do that, I need to write this code here, but that's going to be cumbersome, right? Callbacks inside a callback inside a callback. Oh, no, I don't want to do that, right? Nobody wants to do that. So let's rewrite this code. Remove it, this here, and instead of send, I'm going to use Eric send. And if I use Eric send, now I have a single. A single is a data stream of one item. And if I have a single, as it's a data stream, I have many, many operators on it. Actually, I don't want this. What I would like, because we have seen it's a JSON object. So I want a single of a JSON object. So let's extract the body from this. Body is JSON object. There we go. Make it beautiful, IntelliJ. So now I have the same thing. I've just extracted the body, and actually, what would be good is to not have this, but I'm interested by only this item here. So I will just do JSON get string account. And now I've extracted in 3 lines this line, or this data here. So, but I need to call 2 other services. So this is my account number. And I need to call, so my first service is, let's say, dept, get slash dept slash account, okay. That will be my, let's call that dept G. Oh, okay. No, you don't want? D. Yes. And I will do the same with the balance that I will call Bay. I'm not very creative in terms of naming. And that should be fine. And now, so I got my first call, then I dispatch 2 calls, but I want to do them at the same time. Let's do this. I will use an operator called zip, which I pass a set of data stream, and when all of them has been completed, so receive a value, D and B, I told you, I'm really not creative. I just want to create the new JSON object that I want to answer to my users. So this is going to be return new JSON object. So you may be surprised, but as Vertex is doing a lot with JSON, we have our own API, very simple. I will put the account name into account. I will put my dept level. Just want to be sure. Yeah, so that's level. I will modify this. I don't want this. Let me redo that. I want a double here. And this will be map resp as body as JSON object. JSON object, yes. Yeah, I know you don't compile. Map JSON. JSON dot get double. I'm just extracting what I want from my answer. It is. And I will do the same thing here. Oops. And instead of level, it's going to be balance. That's why I have some to-dos, because I can be easily, oh, and here it's balance. Okay, and this is another double. Okay, so now here D and B are double, so I will just say D and dot put, let's say balance and B. Okay, so I return that, but data streams are lazy structure by default, so I need to subscribe on it. I will use this version where I have the result and the error, which is kind of cool because if you do node stuff, you will realize that they do exactly the opposite. Error first and the result second, because they are living in a very pessimistic way where they believe that error happen more often than results. I'm more optimistic. If the error is not null, then we failed, sorry, I'm going to generate my 500. This is obviously customizable. And if I have the result, I will just say, okay, just send that to my response, and here we go. We have our new API calling all my 3 services. Oh, let's make it beautiful, yeah. Okay, that was just for this. There we go. We should be there now. Yes. And now let's see if I'm not that bad. I have some money on my bank account, and my debt level is not that bad. Good. First example. I have now one new API that is developed by orchestrating some other call, calling one and then calling Q1, all single-threaded. And you can say, yeah, that doesn't scale. Actually, it does scale. It does scale better than any thread pool-based solution. This is made for a cloud and container world where it will use the resources of your system, not much threads, just one, handle everything, handle the load. Just to have an example, Vertex, such kind of application like that, can handle on a Raspberry Pi 10,000 requests per second. 10,000, without any tuning. Just because the model behind, because it's an asynchronous non-blocking development model, make it very easy to do. All right, and we have developed 40 line of code for this. That was the first one, but I told you that we are going to develop a second one. Data streaming, because you may have heard that microservices should be event-driven or message-based, and that's right. It's absolutely right. But I don't want to redevelop another microservices because the previous example could be seen as a microservice. I want something more like in the data pipelining things. I will have fake sensors using MQTT, sending MQTT messages to a Vertex MQTT server. It's not a broker, it's a server. And because it's a server, I can receive all messages and decide to do whatever I want. And that's because I'm not a big fan of MQTT, I'm going to send that to Kafka, because Kafka is cool, and everybody wants to use Kafka. So I'm going to get the message, send them to Kafka. Now that's stored in this big Kafka stuff, but I need to do some processing on it. So I'm going to do a Kafka reader that will retrieve all those messages from Kafka, do some fake processing on it, computing an average, do some kind of things, and say, yeah, but I need something more visual to see what my value has. And I'm going to send those data to the Vertex Event Bus. So the Vertex Event Bus is the spine of our Vertex application. It's just a very simple message bus that can be clustered or local. Here I'm going to use local. But because it's very simple, it has bridge. And I'm going to send this data via a SockJS bridge to my browser. So this is going to use a WebSocket, but because I'm using Chrome, but if you use Internet Explorer 6, it will still work using a very bad iframe hack. But it will still work, which is fine. And you should not use Internet Explorer 6, by the way. But well. So let's do this demo. This is stopped. Okay, let me stop this too. That was my legacy services. So I first need an MQTT server. I will do an MQTT server. MQTT server. Server. I'm never. Okay. I will create it like this. And when we have an MQTT server, we need to, like for HTTP, register a endpoint handler that will be called every time that we have a MQTT client connected to this server. So I will just do client connected, so add a trace just to have an idea if this works or absolutely not. Get client identifier. Okay, so now if I run this, going to be a main to run. Oop, yeah. No, restart. I just want one client. I'll just create one MQTT client. Actually, MQTT client is also a Vertex app in that case, but we don't really care. It can be a true device. And it starts, so yeah, because I'm starting Kafka in the back, it's take a bit longer to start. Come on. No? Let's have a look. Why does not do anything? Oh yeah, sorry, I forgot one thing. I forgot to say that we're done. I need to listen. And I need to say that we, not Eric's listen, yes, Eric's listen, okay, to completable, okay. I will explain this. And now subscribe, completable helper dot to observer future. So in this method, I'm passing a future because starting an MQTT server and so on can take some time, and I want to be sure that before starting all the rest of my application that this is started. So in this second start method, I have this future here that will let me report when my deployment has been successfully done and completed or failed. And to do that, I'm just starting my MQTT server, say, okay, register on the port that has been configured, which is the default MQTT port, and when you are done, tell me that you are done. So as by default, it returns some, I think it's the MQTT server that is returned. Yeah, I don't care. So to completable, completable is a data stream without any data. Just tell me when it's done. And I'm just doing a subscribe because by default it does nothing. See, it does absolutely nothing. And then I just say, okay, now report your result on the future. So if it failed, then it will mark it as a failure. If it's successful, then everything is fine. Let's redo that. Okay, and now we have a client connected. Good. So, but does this client send me stuff? So I need to do a publish handler here, and I'm going to get a message. And let's try to see what do we have in this message. Again, we can just try and try because it's very fast to start. I will just say received message.payload. Received. Yeah, and MQTT, I don't know if you are familiar with MQTT, but there is this topic ID. So I will just write the topic name and done. Let's restart this. And Zookeeper is still not happy. Yeah, need to check why. I didn't update my Kafka to the 1.0 because 1.0 was released 2 days ago. I was thinking a bit not very confident that it would be working. Oh yeah, and I forgot one thing again. That's why it doesn't work. Accept. I need to accept the connection, or by default it doesn't do anything. Well, it rejects the connection. It's just to avoid overloading the server. The server can decide whether or not he accepts the IoT sensor connection. Oh, and here it is. So now we are receiving these payloads from the server. So I don't know if you see just an UID of my sensors and some data, which is random data, and the topic is /data. Okay, cool. Let's go a bit further with this and try to see what we can do and write this into Kafka. So I have a Kafka write stream here, and I'm going to just do stream.write get I've created a method for this. I just need to check the method. Create record here. I need the UID, which will be message.payload to JSON object. Okay, this is going to be object get string UUID, and then object. What would be the just the data get integer, yeah, data. What do we want? Oh, here, okay, even better. That's probably what I was expecting. So now, every time we got something, I'm going to write it to Kafka. Done. And if you want, if you want to look at how Kafka is configured, it's just a regular configuration of Kafka. Obviously, I could have loaded this from a properties file because Kafka is a lot about properties, but I just wrote it down because yeah, I can do that. Okay, so now I'm writing to Kafka, but I need to read it on the other side. It's what I'm going to do here, and same thing. I'm going to have a Kafka consumer, and I'm subscribed to the data Kafka topic, so not the MQTT topic, but a Kafka topic, because I also have a topic ID, I've transformed that to a flowable. A flowable is a stream of data that handle back pressure for me. And I'm just interested by the value of the record. So I will take this stream and I will extract the data. Int data. Okay. Then I want to have the last 5 value, for example, okay, and compute the average. So I'm just chaining operation here, and to compute an average, it's match flowable average double. There we go. And this is going to give me a double and average. And every time that I have this, I will just send that to the Vertex Event Bus on the average address. I don't need this, and there we go. So I've read data from Kafka. I extract what is interesting inside this message. I'm just say, okay, give me the last 5, compute the average, and send that to somewhere else. It could have been another Kafka topic, it could be anything, but I just decided to send it to the Vertex Event Bus. So now if I start this, I remove all the trace, so I say, okay, client connected, okay. But now, if I go here, yep, no, I don't want to have the skip you. There we go. And we should have some data soon, yes. But it's a bit slow. Because I need 5 value to compute the average, and I have only 1 sensor that sends 1 data every second. So I need 5 seconds to compute a new value. But in the IoT world, we have much more data. Let's try something. And let's go there, and instead to have 1 sensor, let's get 5 of them. So what it does is say, okay, I'm not going to deploy this vertical once, but I'm going to create 5 instances of this vertical. But because of how Vertex works, it will dispatch those verticals to different event loops, meaning to different CPU core. So on my machine, I have only 4 CPU core, and I have much more vertical here. So we'll just, well, some CPU core will have 2 verticals. And now, if I go back here and I refresh, now I have much more data. And I have something a bit more appealing in terms of doing things. How does that work? I've sent the message from Kafka to the event bus, but this is my browser. And what happened is we have here another router and a bridge that say get forward to the SockJS bridge every message from the address average to the browser that is connected. And here, it's, well, as it's Chrome, is going to negotiate the transport level between my browser and my event bus, and it's going to use a WebSocket. But of course, if you use a different browser or mobile device, it will probably switch to another transport technology, such as SSC or whatever. 3 lines of code for this. Well, start here and here. And this is just because I'm definitely a designer, right? I just pick some random highcharts.com template that I found on Stack Overflow and copy and paste. It works, more or less. All right. So let's back to the slides. Okay. We have seen 2 demos. One which is more edge services, where you need to develop a new API, very resilient, very responsive in face of failures and so on. And that's typically open banking kind of things or API gateway kind of use case. We have also seen a completely different use case about data streams, where I got several protocols and I want to chain transformation over that, and that's just the first 100% of the Vertex ecosystem. That's just the beginning. Because Vertex, in the last couple of years, let's say 2 to 3 years, got more than 1,000 contributors. Not always active. Please don't, because that would be a lot of PR to review. But 1,000 is already a nice community. We have things for everything around microservices, service discovery, circuit breaker, health check, config, retry, timeout. Everything is supported. So if you want to do such kind of thing, we have it. You use different message technologies. We have already used Kafka and MQTT, but we can use Rabbitmq, very cool. But it's IMQ, so that's a fun thing. Rabbitmq is IMQP 0.9, and what I call IMQP is IMQP 1.0. And if you take the two specs, there's absolutely nothing in common except the name. Crazy, but yeah. MQTT, Stomp, Kafka, and we have Bridge with Apache Camel, which is an integration layer, so we can integrate Vertex application with almost anything in an asynchronous way. And for people interested by all back pressure and so on, we support back pressure in Camel. We support HTTP 1.0, 1.1, HTTP 2, of course. gRPC, we have our own compiler, so we just generate the right data construct for Vertex for gRPC. Service proxies, which I generally say it's Corba made right. Kind of weird, but it's just an RPC mechanism on top of the event bus, completely asynchronous. TCP, UDP, DNS. Oh yeah, DNS is an interesting use case because every time you write a new URL in Java, in your Java code, new URL, I don't know, google.com, you need to know that this is blocking. And if your DNS server is very slow, your code is going to be very, very, very slow. So we have our own DNS resolver in Vertex, which is asynchronous. You are more a prod guy, so we provide metrics for Prometheus, Ocular, Drop Wizard, and I think we have a fourth one. We have a shell if you want to interact with your application and ask her how it is going and so on. We support Docker. We are actually a Docker native runtime in the sense that we are really using efficiently the memory and the CPU. We can speak about fat jars. Vertex fat jars are low fat. Vertex fat jars are probably the one I've done here is probably 5 megabytes compared with what you can do with big fat jars that we are seeing on the market today. We support Consul, Kubernetes, Vault for secrets, because don't write your credential inside your code. That's not a good idea. And so on. We have a clustered event bus, so it's the same event bus, but among different nodes. Bridge with SockJS, that's the one I've used. TCP, we have bridge specific to language, like Python, C#, C, and so on. And we have also data layer. We have JDBC, but JDBC is by spec blocking. So what we do, because Vertex is able to do that, is to delegate this to a worker thread pool. But it's not really what we want to do, because obviously worker thread pool means that you have a thread pool, and we are back to the first problem. We don't want thread pool. Fortunately, for MySQL and Postgre, we have a completely non-blocking and asynchronous driver using the protocol of MySQL and Postgre. If one day Oracle opens its protocol, we can do that for Oracle, but I doubt this is coming tomorrow. Support for Redis. Redis is completely asynchronous. Mongo 2, we have support for authentication with many, many things. Be careful if you use Shiro. Shiro is blocking, so we are using the same construct than we do from JDBC. OAuth 2. JWT, JWT. I learned this morning that it's pronounced JWT, and so on. So, just to conclude, we are now living in an asynchronous world. Actually, we were always living in an asynchronous world, but in the 80s, we realized that asynchronous is hard, so we make the developer develop things the synchronous way. So now, most of our API are synchronous and are using blocking I/O. So we need to change that. And Reactive is a new way to finally catch up with our asynchronous world. Everything around us is asynchronous. Think about it. When I do keystrokes, this is asynchronous. So my operating system is asynchronous. Remote connection are asynchronous. File system are kind of asynchronous. Not for the right, because that can be very interesting. But, well, we have reactive systems. That's what you want to build. Better distributed system, or distributed system done right. Systems that are responsive, elastic, and resilient. To do that, because it's hard, we are going to use, or at least it's what I've shown, reactive programming. It's one way. There is some other way. You can use Fiber with Quasar, which is a kind of a coroutine directly at the JVM level. If you use Kotlin, we also support, oh, what is this? Oh, yeah. We are JavaDay, so that's cool. That just tells me that there is an update. No. Yes, I'm done with my demo, but yeah. So if you're a Kotlin lover, and Kotlin is a very great language. If you don't know Kotlin, look at it. It's really refreshing from the Java world. It supports coroutine. And you know what? Vertex supports Kotlin coroutine. So you can write all the code I've done with RX using coroutine in a synchronous way in terms of writing, but actually the execution is asynchronous and non-blocking. This is very cool. If you use reactive programming, don't forget reactive streams. You don't have to care about it because new generation of reactive programming libraries such as Reactor from Pivotal or Eric Java, which is the one I've used, Eric Java 2, are based on reactive streams. And we will find a lot more components using reactive streams as way to interact. Actually, reactive streams, which was a separated specification, is now inside Java 9 under a new name. It's named Flow. As they change the package name, it doesn't compile if you switch to that one. So we'll take some time before we really start using Flow. But if you are tired to follow the rules from a framework, if you are tired to use 10 annotation on every member where you have no idea what they do, but you just do them because Stack Overflow tell you to do that, if you really want to have more freedom and fresh air, try Vertex. You are back in charge with Vertex. You don't let a framework lead. You decide how you want to shape up your system. We have been built to do this. But to do this, because it's hard, we take this CINI, we put them together, and we'll give you the magic recipe to do what I just done. Two completely different examples in 50 minutes. If you want to go further, you can check this book. It's free. It's only 70 pages, so I don't know if you fly to Kiev, but you can just read it in the plane. It will tell you a lot more about Vertex itself, about how to build microservices. We have another book, which is not published by an editor, but it's, well, at the beginning it was a guide, and when the guy, so Julien Pons, finished to write it, it was almost 100 pages, so we said, yeah, for a quick start, let's call it a book. So we have another one, so check on vertex.io, you will find both. Both are free. You can download that one from that one. If you have any question, you can contact me on my on Twitter @ClementPlop. I'm not proud of it, but yeah. Or directly by email, clement@apache.org. And we have 6 minutes for question. Thank you. Yes. Well, anyway, I will repeat your question. So,
you said that Vertex is distributed, right?
Yes.
So how do we achieve distribution? We start our processing pipeline on one node in our cluster, yeah? And if we have several nodes and one of them fails, what happens then?
It will depend on the protocol you will use between your nodes. So if you use the Vertex Event Bus to manage your clustering, then it will just dispatch to a subscriber on the same address, but registered on another node. And better thing, if you have enabled HA in Vertex, so just a flag, if your vertical crash without saying goodbye, we say, oh, you crashed, and we will reinstantiate it on another same node of your cluster, out of the box. However, if you are using Kubernetes or Mesos, they already have such kind of features too, so you need to be sure to not conflict. So depending where you are running, choose what you want to enable, but because, yeah. If you use Kafka, for example, well, resilience is built in. They're very great about that. So if my consumer failed or one of my publisher failed, everything is still up and running. Another question? We still have 4 minutes to kill. Yes, over there. Doesn't work. If you come here, the first line, so I can just repeat the question. But here, I just see, networks fail.
Can you hear me?
Yes.
Okay. Sense of presentation, first of all, and my question is about Vertex and how does it compare, for example, with Kafka Streams API? Because they are basically doing similar things, and how do you see the use cases? When you will use Vertex and when will you use Kafka Streams API?
So actually, that's a very interesting question. Generally, we ask me to compare Vertex to Akka. Akka being a pure actor model built in the vein of reactive systems, but in Vertex we took some freedom. It's part of the Vertex essence, how we wanted to implement it, and because we wanted to be a bit more hello, HTTP, HTTP2, gRPC, and stuff like that. But your question is about Akka Streams. So for people not knowing Akka Streams...
Kafka Streams, sorry. Kafka Streams.
Oh, Kafka Streams. Oh, sorry, I heard Akka Streams. But Akka Streams and Kafka Streams, man, they're very close, are actually very close technologies because both are based on Kafka and both are a fast data pipeline or streaming platform. They all provide operators to do things and to process your data. Question is, what happens if you want to send your data not to Kafka, but to AMQP or to something else, or write them to a database? Because maybe you want to write your data in a database at some point, or call some weird machine learning things. Not something like Spark and Flink that everybody is supporting, but something very weird, because everything's very weird in the machine learning space. In that case, you need a bit more freedom, and we provide this freedom. So it depends. As soon as you are still on track with what the technology can do, use it. But if you know that at some point things can go south, we let you manage that.
Okay, thank you.
We have 2 minutes. Another question? And if you don't know Akka Streams and Kafka Streams, check them. They are very cool. Akka Streams, well, if you read Scala, I really like Akka Streams in Scala. So if you like Scala, look at it. It's very, very cleverly done. It's a bit like Spring Data Flow, but all based on Kafka and back pressure.
Sorry, one more question.
Yes.
Is there any, let's say, event sourcing like implementations for Vertex?
Sorry?
Or is it any event sourcing like implementation for Vertex and maybe something CQRS and things like that? Out of the box?
Out of the box, no. However, if you want event sourcing, I can't remember the name. There is a very cool RX-based Groove. Do I have internet here? Yeah, I probably have. So let me GitHub. Groove. Not Groovy, just Groove. Groove API. Event sourcing. Yes, this one. We integrate perfectly well with this one, so Grooves, sorry, it doesn't. And it's a pure implementation of event sourcing. It's all RX-based, and as we can consume and manage all RX-based interaction because everything is asynchronous, If you want to do this, use this library. It's amazing. About CQRS, it's more a design issue. If you really want to have your read on one side, your write on the other side, do your API like that way. We let you do that. We don't provide anything to the. I'm not sure that there is a. We could provide some boilerplate, but yeah. Again, shape your system as you want. If you want to have CQRS, just do it.
Makes sense.
Yes?
You showed us that we can use some kind of aggregation operations on the streams. And the question is, does this aggregation happens in memory? And if no, what data store do you use under the hood?
Yeah, in all I've seen, everything happen in memory. And obviously the question is, what happens if you run out of memory? Fortunately, we have back pressure, meaning that if one of your nodes starts to be a bit slower, then we will reduce the speed of the edge producer. And where things start to be a bit more interesting in when this edge producer cannot really handle the load from something else, because that's maybe IoT sensor. And you know what? You cannot stop IoT sensors. They're always pushing data and data and data. In that case, you need to put a layer in between, that like an unlimited buffer or a big buffer. That's probably the most used use case of Kafka today, is to use Kafka as an unlimited buffer. Unfortunately, and we need to be aware of this immediately, there is no unlimited in computer science. We know that there is a limit at some point. When this limit is reached, good luck. It's probably a file disk, running out of file disk, well, file space on your disk. Well, you can always add an USB key and stuff like that, but yeah, kind of tricky. We ran out of time. If you have any other question, just contact me on my mail address or on Twitter. And thank you very much. Oh, and if you're into